Welcome, students. In today's deep dive, we're going to explore a really foundational concept that bridges pure mathematics with powerful business strategy. We're talking about scalar multiplication. Now, this isn't just about crunching numbers for the sake of it. This is about understanding how you can model massive systemic changes within a company with absolute precision.
So, let's start with a strategic question that every single one of you, as future business leaders, must consider. How can one single number, just one, change an entire business model? I mean, think about that for a second. A single decision to raise prices, to cut a budget, or to increase production can ripple through an entire organization. And today, we're going to unpack the mathematical tool that lets you control those ripples.
Okay, here's our roadmap for this lecture. First, we'll look at the big picture, the mathematics of scaling. Then we'll define our core terms, so we're all speaking the same language. From there, we'll walk through a step-by-step calculation to see the mechanics. Then, the fun part, a real-world application involving a price increase. And finally, we'll cover how to avoid some very common pitfalls.
All right, let's begin. Section 1, the mathematics of scaling. I like to think of this concept as the master dial for business operations. Every business at some point needs to scale things up or scale things down. And it has to be done uniformly and efficiently.
Think of a matrix, which we'll define in a moment, as a kind of business dashboard showing all your key data. Scalar multiplication is the master dial you turn to adjust that entire dashboard, up or down, in one single, decisive move. Maybe you need to increase every department's budget by 3%, or maybe you have to cut production targets by 5% across the board. You need a tool to do that consistently, and this is it. Now, let's establish the precise vocabulary we'll be using. Mastering these terms is absolutely fundamental. In the world of business mathematics, using the right language isn't just about sounding smart, it's about ensuring clarity and avoiding very expensive misunderstandings.
First, the scalar itself. So what is it? Well, it's a single real number that acts as our scaling factor. But in a business context, it's much more than just a number. It's the engine of the change we want to implement. It could be a growth rate, a price adjustment, a budget cut percentage. It's the strategic decision distilled into one powerful figure.
Next up, the matrix. A matrix is simply a rectangular array of numbers, all organized in neat rows and columns. I want you to think of it as a snapshot of your business data at a particular moment in time. This could be your price list, your inventory levels, or your regional sales figures. It's the organized set of data that we need to act upon.
And this brings us right to scalar multiplication. This is the operation itself. It's the process of taking our scalar, our strategic number, and multiplying it by every single element inside our matrix. The result is a brand new matrix of the exact same size, showing us our transformed business snapshot.
Okay, let's move from theory to practice. It's time to walk through a purely mathematical example just to see exactly how this works. We need to get comfortable with the mechanics before we can apply this with confidence in a business setting. Here is our problem setup. Let's say our scalar, which we'll call k, is equal to 2. And our matrix, matrix A, is a simple 2 by 2 matrix with the elements 1, 2, 3, and 4. Our goal here is to calculate the new matrix, which we'll call Ka.
So how do we do it? Well, the process is wonderfully systematic. We take our scalar, 2, and we distribute it to every single element inside the matrix, one by one. So 2 times the first element, 1, equals 2. Then 2 times the next element, 2, equals 4. We move to the next row. 2 times 3 is 6. And finally, 2 times 4 is 8. See that? It's a uniform application across the entire data set. And as you can see, we've created a brand new matrix, Ka, with the elements 2, 4, 6, and 8. Every single value from our original matrix has been scaled by our factor of 2. It has been perfectly doubled.
Now here is a crucial point to remember. Scalar multiplication does not change the dimensions of the matrix. Our 2 by 2 matrix is still a 2 by 2 matrix. Why is this so important in business? It means the fundamental structure of our data remains intact. We've only scaled the values within that structure. This preserves the integrity of our data model, which is absolutely critical for analysis.
This is where it gets really interesting. Let's apply this mathematical tool to a realistic business decision. We're going to dive into a case study about a coffee shop to see how this plays out in the real world.
I want you to imagine this is the current price matrix for a chain of coffee shops. This is our business snapshot, our matrix A. The rows represent the different drinks, latte, cappuccino, Americano, and the columns represent the sizes. This is our current state of affairs.
Okay, now here's the directive from management. The goal is a uniform 10% price increase across all items and all sizes. Why? To cover rising costs, a very common business problem. Now, that key word here is uniform. As soon as you see that word in a business problem, your brain should immediately think scalar multiplication.
So the next question is, how do we represent a 10% increase as a scalar? Now be careful here. This is a common place for error. You might be tempted to just use 0.10, but that would only calculate the amount of the increase, not the new final price. We need 100% of the original price plus that extra 10%. So our scalar, k, is 1.0 plus 0.10, which gives us 1.10.
And this brilliantly illustrates the outcome. By multiplying our original price matrix by that scalar, 1.10, we instantly generate our new updated price list for every single product. The small latte is now $3.85, the large Americano is $3.85. The entire menu is updated in one clean, efficient, and error-free calculation.
Now, before we conclude, it's vital to discuss a common mistake I see with students applying this concept for the first time. In business, even a small error in your calculations can lead to significant problems down the line, so ensuring accuracy is paramount.
So, what's the mistake? It's selectively applying the scalar. For example, only applying the price increase to the large drinks. That is not scalar multiplication. The power of this tool lies in its uniformity. If you start picking and choosing, you fundamentally misunderstand the principle and you'll distort your pricing structure, which could have serious negative consequences on sales. Remember, the scalar must be applied to every single element.
So I'll leave you with a final thought to test your understanding. If a 10% price increase uses a scalar of 1.1, what scalar would you use to model a 25% company-wide budget cut? Think about it. If you're cutting a budget by 25%, what percentage is left? You're left with 75% of the original, so your scalar would be 0.75. Understanding this versatility, the ability to scale both up and down, is what makes this such an indispensable tool in your business toolkit.